Thank you for clicking on that thumbnail and watching this video. If you like this video, please share with your friends and subscribe to my channel. I will make many more videos like this for you. Let's start with question number 1. Two particles P and Q of mass these respectively are at rest on a smooth horizontal plane. So this is like this. This is P and this is Q. The mass here is 0.3 kg. This is 0.2 kg. P is projected at a speed of 4 meter per second directly towards Q. So this is projected towards Q and speed is 4 meter per second. And since they have not mentioned anything else and they have said it's a smooth horizontal plane, that means the speed before colliding with Q will still be 4 meter per second. There is no resistance. After P and Q collide, Q begins to move with a speed of 3 meter per second. They don't know what happens to P, but Q moves with 3 meter per second. Obviously in this direction, because if it is stationary, they're saying at rest, right? They have mentioned here at rest, and then they say Q begins to move. That means it is initially at rest. Find the speed of P after collision. So we will use conservation of momentum. So according to conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Since these two objects remain two objects, so we will write them separate. Mass of the first one is 0.3 and it is moving with a speed of 4 meter per second, collides with the one with 0.2 kg, no speed, it is at rest. But after collision, we don't know what happens to m1 0.3 because they're asking the speed of P after collision. So we don't know. But we know that m2 was moving with a speed of 3 meters per second. So we can do here 0.12 plus 0, no need to write, 0.3 v1 plus 0.6. Subtract 0.6 from here and subtract 0.6 from here also. We are left with 0.6 equal to they cancel 0.3 v1, divide both sides by 0.3. v1 comes out to be 2 meters per second. That means P moves at 2 meters per second after collision. Alright, there is B part which says after collision Q moves directly towards the particle R. Okay, so this is Q coming from somewhere. At what speed? We got 2 meters per second. Its mass is 0.2 kg and comes towards R. Alright, with mass m kg, we don't know its mass. Obviously they will ask for it, which is at rest. So u2 is 0 in this case. The two particles Q and R coalesce on impact and move with a speed of 2 meters per second. Coalesce means they become one body. Q becomes m1 this time, so its mass is 0.2. It is moving with 3 meters per second. That's what there in P first part, right? P is at 2 meters per second. Q was moving at 3. Now second body is m2. We don't know what is the mass, but they have said that its mass is m. So we will not write 2, just m. It is at rest. After collision, both of them become one body, coalesce. The 0.2 plus m, and they are asking what will be, sorry, they have given the speed. So what are they asking? They are asking m. 0.6 plus 0 equal to 0.4 plus 2m. 0.6 minus 0.4 is 2m. 0.2 equal to 2m, so divide both sides by 2. M comes out to be 0.1 kg. That is the mass of the third body R. Okay, question number 2. A particle is projected vertically upwards from horizontal ground. Okay, so if this is the ground, it is projected upwards. Okay, it goes up. All right. P reaches a maximum height of 45 meters. After reaching the ground, P comes to rest without rebounding. That's very difficult to happen, but yeah, they don't want to confuse you that it goes up again and something happens. So that's why they're mentioning that it does not rebound. Okay, find the speed at which P was projected. So we want to find a speed with which it was projected upwards so that it reaches a maximum height of 45 meters. So we know that when something reaches at the highest point, it stops. So that means V becomes 0. We want to find U, what is it? So we can use this equation 2as equal to V square minus U square. So we have 2. Acceleration is downwards because it is being thrown up, but due to gravity, the deceleration is downwards. So minus 10 meters per second per second square will be the deceleration. It moves a distance of 45. Displacement is 45. So V square is 0. U square we want to find out. Minus 900 equal to minus U square. Both are negative, cancel them out. Square root, we will ignore negative because velocity is positive, we know that. So U is 30 meters per second. Find the total time for which the speed of P is at least 10 meters per second. Alright, so it is being thrown up by a speed of 30 meters per second upwards. So it will become slower, and here it becomes 0 meters per second, correct? That means 10 will be somewhere in between. Suppose here it is. So they're saying, find the total time for which the speed of P is at least 10 meters per second. So at least means 10, 10, 11, 12, 15, 20, 25, 30. This and from the same height downwards here. These two places, it will be more than 10 meters per second. It is a rule that at the same height, if there is no air resistance, the velocity is in opposite direction, but the speed is same. The magnitude is same. All right. So I will just find for this and I will just double that time. And we will use this simple equation for this. V equal to U plus AT. We want 10 meter per second to be the velocity, the final one. U is 30, we know that. And acceleration is minus 10 in opposite direction, and time we want to find out. So 30 goes to the left side, 10 minus 30 will be minus 20, right? Or rather, let me do it clearly. Equal to minus 10t, divide both sides by minus 10. So we get t equal to 2 seconds, minus 20 over minus 10, 2 seconds. But 2 seconds is from this 30 to 10, but from this 10, just before hitting the ground, it will be 30 meters per second again. I told you at same height with no air resistance, it's always the same speed. So 30 meters per second. So this will also be 2 seconds. So total time, they're saying total time, right? So total time for speed greater than or equal to 10 meters per second is 4 seconds. 2 seconds time 2. Let's move on to the next one. Question number 3. The displacement of particle moving in a straight line. For that, the graph is given here and they have given some detail. You can pause the video and see the details yourself. Distances OP, OQ and OR in 50 meters, 150 meters and 200 meters respectively. They have given the distances traveled in these A, B and C points. They are respectively physically at P and Q and R places. The diagram shows a displacement time graph, and everything is there. Find the speed, not velocity, speed of the particle between t equal to 5 and t equal to 10. So this is t equal to 5, this is t equal to 10. That means this straight part BC is the section where they are asking us to find the speed. For speed, we need distance and we need time. So distance here from this level to C, which is this level, that is 5 to 10 seconds, is it's 100 meters. Divided by time is 5 seconds. So the speed becomes 20 meters per second. There is no turning point. Straightforward answer. B. Okay, let's move to B first. Find the acceleration of the particle between t equal to 0 and t equal to 5. The acceleration here. Okay, since the acceleration is constant, so we can use formula. So we can use this formula, s equal to ut plus half at square. S is 50 meters and starts from rest. The particle starts from rest and passes through PQR. So 0 times how much seconds? 5 seconds. Okay. Plus half acceleration we want to find, but we know time again. So this is 0, 50 equal to 25 divided by 2 is 12.5 A. Divide both sides by 12.5 and A comes out to be 4 meters per second square. Okay, is there any C part? Yes, it is. Find the average speed of the particle during its motion. For speed, again we should know the turning point. There is a turning point at D here. That means the distance it traveled up to D is 200 meters. So speed is again distance divided by time, and distance will be 200 in one direction and then it comes 200 back and starting point. So total 400 meters it went, and time taken was 20 seconds. So it becomes 400 divided by 20 meters per second. Okay, next question. The diagram shows a block of mass 10 kg suspended below a horizontal ceiling. Okay, so that means it is fixed here. Okay, by two strings AC and BC, the length 0.8, 0.6 respectively, attached to fix the points of the ceiling. ACB is 90 degree. Okay, so 90 degree helps us to find the hypotenuse, right? Because if one side is 0.8, one side is 0.6, we can find third side, which is AB, and that becomes the hypotenuse. So it comes out to be how much? 0.8 square plus 0.6 square by Pythagorean theorem and square root. That's how we'll find AB, which comes out to be 1 meters. So this side is 1 meter. Now they're asking, in case where F is 20, this F is pulling it to the right side, find the tensions in the E string. So we need to know the tensions in these two strings. For that we need to draw the free body diagrams. So let me do it here. So there will be weight of 100 newtons downwards. There is a force of 20 newtons this way. And now I'm focusing on this point. So there will be a component of this force, this tension. Let's call it T1, this one, and this one T2. So there will be a component of T1 in this direction, and if we know this angle, it will be there. So if I complete this becomes 90 degree. This angle will be exactly same as this angle. Why? Because this whole triangle ABC is congruent to let's call it O. So OBC, rather B is the middle angles, B is this angle, so I should use C as the middle one, ACO. Let me show you how. This angle is 90 degree, so the bigger one also has this angle 90 degree, right? This angle is common between the big triangle ABC and ACO, isn't it? That means the third angle, remaining angle, will be equal to the remaining angle of the triangle, right? So if this is theta, this is going to be theta. Let's call this one alpha. This will be alpha, right? So now let's get, because we'll need sine alpha, cos alpha, sine theta, cos theta. Let's write them. Sine alpha, according to this alpha, will be opposite 0.6 over hypotenuse, which is 1, right? Now sine cos alpha will be adjacent to this alpha is 0.8 over 1, which is 0.8. Sine theta, this is the theta, so opposite side is 0.8 divided by 1, I'm not writing now, and cos theta is 0.6. These will be needed. All right, T2 cos alpha. Again, there will be a component of this T1 also in this direction, which will be T1 cos theta. There will be a component of T1 here, T1 sine theta, and there will be T2 sine alpha here. So let's see if everything is there. Two forces upwards because of these tension. This is this way. I have counted this. One component this way, one component this way, 100 Newton. Everything is there now. Now we'll get some simultaneous equations. Let's make for vertical forces. Since it is in equilibrium, right? The block is in equilibrium, so we have to equate T1 cos theta. Cos theta we just found out, cos theta was 0.6. Let me write here 0.6 T1 plus T2 cos alpha. Cos alpha is 0.8. Will be equal to 100 newtons, which is downwards, right? So let's isolate one of the forces. Let me isolate T2. So 0.8 T2 will be 100 minus 0.6 T1. So T2 will be 100 minus 0.6 T1 divided by 0.8. Equation number 1. Now we'll compare the horizontal forces. Okay, T1 sine theta. Sine theta is how much? 0.8. Equal to 20 is on right side, and T2 sine alpha is also on the right side. 0.6 T2. So now T2 is here. We will substitute this T2 with that one now. So 0.8 T1 equal to 20 plus 0.6 100 minus 0.6 T1 over 0.8. Let's multiply the whole equation by 0.8 so that this 0.8 goes. 0.64 T1 equal to 20 plus, now 0.8 is gone, no, I have to (20 times 0.8 will be 16 plus 0.8 is gone from this side, so 60 minus 0.36 T1. Alright, 16 plus 60 is 76 equal to 0.64 T1 plus 0.36 T1. 1, this is 1. So T1 equal to 76 newtons. And we can get T2 from here. 100 minus 0.6 times 76 over 0.8. Let me use my calculator for this. By the time I do this, I will request you to like this video, share with your friends. The paper has been out just yesterday and I'm preparing this solution video for you. If you like this video, share with your friends, subscribe to my channel. I'll make all the exams available right now. So once I use my calculator, I get 68 newtons. So T1 and T2 both are known to us now. Okay, what next? Find the greatest value for F for which the block remains in equilibrium in position shown. Greatest value. So there will be this F which will increase this tension and reduce T2. T1 will increase and T2 will decrease if we pull it this way, right? There will be a point when this T2 becomes 0. That will be the greatest force which will keep this in equilibrium. We want T2 to be 0. So in this drawing, if I make T2 equal to 0, that is the value of F, and this is what I'm going to do now. So I have drawn it here. So there is no T2 anymore. This is gone. This T2 will also go, right? And this 20 Newton is unknown now, right? So this will be F here. So now we want this system to be in equilibrium. So T1 cos theta equal to 100 newtons, right? And T1 sin theta equal to F. So from this first equation, let's find T1 equal to 100 over cos theta. What was cos theta? Let's go back and see. Cos theta was 0.6. Okay, so it becomes 100 over 0.6. Let's put that is T1. Let's put that T1 here. 100 over 0.6 and sin theta would be 0.8 equal to F. And this decimal cancels with this. 3, 4. F comes out to be 400 over 3 newtons. Are they saying exact value? Okay, they're saying greatest value, so let's keep it like this. Question 5. A cyclist is riding along a straight horizontal road. Okay. The total mass of the cyclist and her bicycle is 70 kg. At an instant, a specific instant, okay, when the cyclist's speed is 4 meters per second, her acceleration is 0.3. There is a constant resistance motion, 30 newtons. So there is a resistive force which is 30 newton. Find the power developed by the cyclist. So power is always applied force. Only the source has the power, nothing else, multiplied by the speed at which it is moving. So speed we have 4. We don't have applied force. So let's say that there is a 700 Newton force because of the weight. There is a resistive force of 30 Newton here, and there is an applied force in this direction. So the net force, which is mass times acceleration, will be the applied force minus 30 newtons. You can say resistive force. Mass is known to us 70 kilograms. Acceleration is also given to us at that instant 0.3 equal to applied force minus resistive force is 30 newtons. This is 200, no, how much? 21 plus 30, the one we get from here, equal to applied force. So we got F applied equal to 51 newtons. So that's what we'll use here. 51 is the applied force, velocity is 4, and that's why power will be 204 watts. Let's move on to the next one. The cyclist comes to the top of a hill. Okay, that means it was coming from somewhere and it is on the top of a hill, and now it will go down, right? Inclined at 5 degrees to the horizontal. The cyclist stops pedaling and free wheels down. That means it goes down by its own weight. Okay. The magnitude of the resistance to the force remains 30 newtons. So there will be 30 newtons opposite to this force. And what is that force? That force will be how much? The mass is 700 newtons. Not mass, weight is 700 newtons. So the component here will be 700 sine 5 degrees. Okay. Over a distance of d meters. So from here, let's say till here is d meters. All right. It may not be the bottom of the hill. Okay. Okay. It increases from 6 meters per second to 12 meters per second. So u is 6 meters per second and v is 12 meters per second. Find the change in kinetic energy. Change in kinetic energy is half m v square minus u square. So it will be half, m is 70. Okay, v square is 12 square minus 6 square. So weight was of no use. Only change in kinetic energy is being asked. So how much will that be? They can cancel. 35. So delta KE, change in kinetic energy, will be 35 multiplied by 144 minus 36. 144 minus 36 will be 108, and we can multiply, that will be 0.873. 3780 joules is the change in kinetic energy. Is positive, that means the kinetic energy increased, and that obviously because the velocity increased. Okay, what's next? Use an energy method to find D. Okay. So for energy method, we have this formula that the work done by the applied force is the sum of work done by the resistive force, change in kinetic energy, and change in potential energy. Right? Work done by applied force. What is the applied force here in this case? The applied force will be the force that is bringing it down, correct? But keep in mind, whenever we have delta PE, change in potential energy, this is the same. This is basically this work done by the weight itself is the change in potential energy. So there is no external applied force, so we will count it as 0. 0. Now, resistive force is 30 newtons, right? So work done by resistive force will be the resistive force multiplied by the distance it travels with that resistive force. So it is 30 newtons multiplied by D. Delta KE, we just got it, 3780. Now let's find delta PE. Potential energy change will be mg H1 minus rather h2 minus h1. Means h2 is the later height and this is the initial height. So let's redraw this. If this was the height, this will be the h2. It reached some place where the height became 0 with reference to that point. So h1 is h2 is 0 and h1, we know this is d, we know this is 5 degrees, right? So we can say that h2 opposite over hypotenuse is equal to sine 5 degrees. So that gives us h2 equal to d sine 5 by cross multiplication. This d multiplies with sine 5. Okay, so I will write here d sine 5 degrees. M is 70 and G is 10, so we can multiply this by 100. Obviously 0 minus something will give you a negative answer. That means you are losing potential energy. That again makes sense because you are going down, you are losing height. So you have to have a negative this thing, which will be 700d sine 5. In this whole equation, d is the only one unknown and they are asking to find d with the energy method. This is how we'll find it. So 0, let's keep 30d here and bring 3780 to the right side. 3780 equal to 30d and this will be sine 5, 700 sine 5 will be 61. So minus 61d. So that's minus 31d equal to negative 3780. Divide both sides by negative 31, not 61. So d comes out to be, both become positive and we get 121.93. To 3 significant figures, it will be 122 meters. That's the distance it traveled. All right, what's next? Okay, a big thing. Two particles P and Q. Particles are P and Q. Masses the given. Okay, respectively attached with the string. We can see inextensible. Okay, that passes through pulley B. Okay, AB as 60 degrees and the other one is at 30 degrees. The string is taut and particles can move on line of greatest slope of the two planes. This is a formality to write so that nobody objects that information was not given. Okay, what is the first part saying? Let's move it a little up and this is the first part. It is given that plane BC is smooth. Okay, that means there will not be any friction and it is released from rest. U is 0. Find the tension in the string and the magnitude of the acceleration of the particles. All right, so let's do one. Let's focus on this particular particle Q. Okay, so let me draw its forces on it. So there will be a weight down there which will be 2 newtons, right? And there will be a force down because of that weight which will be 2 sine 30 degrees. Whenever there is a slope, the one against this slope is always sine component. The 2 sine 30 is the one which will try to bring it down. And there is also this particular mass is dragging it down. So that means there is some tension extra on this string. So there are 2 forces downwards. What is the force upwards? Nothing, because there is no resistance. The surface is smooth, right? So let's make an equation out of this. We already said that F net equal to MA equal to applied force minus resistive force. So M for this particular particle is 0.2. Acceleration, we don't know. Applied force, we just found these are the 2 applied forces. In this case, the applied force will not be an engine or a person. It is the force that is to towards the motion, the direction of the motion. These two are towards the direction of motion. So t plus 2 sine 30. Sine 30 is half. Yeah. So 2 times half, which is 1. Okay. So the acceleration becomes what? T plus 1 divided by 0.2. That's the acceleration. What are they asking first? Tension first. So okay, it's good. We'll accelerate A. Now, by the same string, this second body is attached. Let's see the forces on that body. There will be a force, of course, downwards, just like this, 2 sine 30. Here in this case, it will be 3 because the weight downwards is 3 newtons. Its component will be 3 sine 60 this time because this plane is at 60 degrees. And this surface is also smooth. Yeah. So both of them are smooth. So only tension will be the force in this direction. So let's use the same formula for this case, which will be 0.3a equal to 3 sine 60 minus t this time over 0. No, nothing. It will be just, that's one. This is not divided by anything. So acceleration in this case will be 3 sine 60. Sine 60 is square root 3 over 2 minus t and divided by 0.3. Now you can see that this equation was in form of acceleration. This was also for acceleration. We can equate the two. Let me equate them here. So t plus 1 divided by 0.2 is equal to, let me cancel these two. So it will be 1.5 square root 3 minus t over square 0.3. Our purpose is to find t. So let's cross multiply. So it becomes 0.3t plus 0.3 equal to 0. Times 0.2 times 1.5 is 0.3 again. Yeah, square root 3 minus 0.2 t. Okay, t's and t's can be together now. 0.3t plus 0.2 t equal to 0.3 square root 3 minus 0.3. It becomes 0.5 t equal to 0.3 square root 3 minus square root 0.3. Divide both sides by 0.5 to get t, and I'll use my calculator to do this. Let's cancel this one. Is 0.439 newtons. That's tension. They are also asking acceleration, so we will use this equation for acceleration. So acceleration will be 0.439 plus 1 divided by 0.2, which is approximately 7.195. Again, we can round it off to 7.20. 3 significant figures, meters per second square. That's acceleration on both of them. Let's move on to the next one. Okay, it is given that BC is rough now. Okay, so now we have to look at the drawing again and see that it is rough. Okay, a force of magnitude 3 Newton is applied to Q directly up the plane. Okay, so this was it, and this is Q. For this we are applying a force of 3 Newton upwards. Okay, line of greater slope. Find the least value of coefficient of friction. Okay, mu least we want between Q and the BC. Okay, this is B and this is C. This was A. All right, for which the particles remain at rest. That means on this, the all forces must be balanced, and we have to find those forces. So we know this is 2 newtons, this is 2 sine 30 degrees plus the tension in the string. Just like we said earlier, there is a tension in this string, and since this whole system will try to go down, so there will be friction which will be trying to stop it. So these are the four forces on this one. The problem here is that we don't know two things. We have to find mu because of this frictional force, and we don't know tension. Let's find tension from A. So it has 3 newtons down there. So this component downwards will be 3 sine, and angle of 60 degrees, and tension will be upwards, and it is still smooth. Yeah, so there is no other force, so they will be equal. So we can find tension from here. Tension is 3 sine 60 degrees. Because the string is same, because of the pulley here, and the string is same, this T will be the same T. So now we can write the equation for this particular system. So 3N plus F, frictional force, equal to 2 sine 30 plus tension, which is now 3 sine 60. All right, so this is what we have to isolate, and there's no need to write Newton. So F, which is mu R. Yeah, mu is what we have to find out, and R is the reaction force. We did not write reaction force here. Reaction force will be R here, which will be equal to the perpendicular contact normal component of this 2 Newton, which is 2 cos 30 degrees. 2 sine 30. Sine 30 is half. So 2 times half is 1, plus 3 sine 60 is 3, and sine 60 is square root 3 over 2. Okay, this 3 was also there, so minus 3. Now we will write the value of R here. So mu times, what was it? 2 cos 30. So cos 30 is square root 3 over 2. So 2 square root 3 over 2, we cancel this. So square root 3 is the only one left, equal to 1 minus 3 minus 2. So let's cancel this also. 1.5 square root 3, which will be this one, and 1 minus 3 is minus 2. So mu comes out to be 1.5 square root 3 minus 2 over square root 3. Okay, when I use my calculator, I get it as 0.345. That is the coefficient of friction. They said least. Okay, for least I have added this with this force, so that this force reduces this particular force, and it will be reduced because of that, because R is fixed, mu will be reduced. That is the least force. All right, next, number 7. A particle P moves in a straight line through a point O. Okay, the velocity v meter per second of P is given by this, where B and C are positive constants. Got it? At t equal to 5, the velocity is p0, acceleration is this. So this is very special information. So when t is 5, v is 0, and a is negative 13 over 12. We will use this one sometime in future. Show that b is 9 and find the value of c. So let's use this particular information first. It says when t is 5, v is 0. So we'll make this v 0. 0 equal to 9 over 4 plus b 5 plus 1 square minus c 5 square. So every t is replaced by 5, and v was replaced by 0. So what do we get here? We get 0 equal to 9 over 4 plus 5 plus 1 is 6, b over 36, which is square root of 6, minus 25 c. Let's try to make it one equation by multiplying the whole equation by 36. So 0 equal to, because this is 4, this 4 will cancel with 36, so 9, and 9 times 9 is 81. Plus this 36 will be cancelled by 36, so we're left with just B. And then we have 25 times 36 will be 900C. So can we write this as 900C minus B equal to 81? This becomes our equation number 1. Now we will use the second information. When t is 5, acceleration is this, but we don't have acceleration equation. So let's write acceleration equation here by differentiating the velocity equation. So the differentiation of 9 over 4 is 0. Don't even look at this. This one will be b, let me write here, b over t plus 1, we have to differentiate, correct? I'm rewriting this as b t plus 1 to the power minus 2, and this will be easier to differentiate. So this minus 2 comes in front, becomes minus 2b, and the exponent of t plus 1 goes down by 1, t plus 1 minus 3, and further we have to multiply by the differentiation of the base, but it is just 1. The differentiation of t is 1, so no need, we can leave it. Now we have to differentiate ct square, which will be minus 2ct, and now we can substitute this t equal to 5 and a equal to minus 13 over 12. So minus 13 over 12 equal to minus 2b 5 plus 1 minus 3 minus 2c 5. Can we simplify this? Okay, minus 13 over 12 equal to 5 plus 1 is 6. So it will be minus 2b over 216, because 6 cube is 216. All right, minus 10c. Let's cancel 2 and 216, it becomes 108. Okay, they are asking us to show that b is 9. That means c should be eliminated. So let's eliminate c from here. So b will come here, becomes positive b plus 81 over 900. Yeah, because 900 is the coefficient of c. This is what we will substitute here, and we should get our answer. So minus 13 over 12 equal to minus b over 108 minus 10, and it is b plus 81 over 900. I can cancel this 10 with this, so that it becomes 90. Alright, let's take LCM of the whole equation so that we can ignore it. So the LCM of these will be 1080. So 12 times 9 is 1080, and we have 1 0 extra, so 90. 13 times 90 will be minus 1170 equal to minus b. 1180 is already there, we need just 10, so minus 10b. Then minus 10b again, minus, no, there is 90 here, and we need 1080, so 12, we have to multiply this by 12. So 12b minus 12b, and similarly this minus will make this 81 also negative, but this 81 will also be multiplied by 12 because the denominator is just 90, so it will be 972. Okay, so we can ignore the denominator now. This becomes a simple equation, and now we can write it here. So minus 1170 plus 972 equal to, we have minus 10 minus 12, minus 22b. So how much are they? Okay, there is a difference here. So 170 and 28, 198 negative equal to minus 22b. Divide both sides by minus 22, and yeah, b is 9. 198 divided by 22 is 9. We got it. We showed that b is 9. What about find the value of c? We have to find the value of c now. So c we already have b plus 81, so b is here 9 plus 81 over 900, and it becomes 90 over 900, which is 0.1. That's the value of c. Okay. Given that the velocity of p is 0 only at t equal to 5, find the distance traveled in first 10 seconds. So first of all, you should know that whenever velocity is 0, that means it turns. So if it is going in straight line, after 5 seconds, at 5 seconds it is turning back. T equal to 5. And they are asking up to t equal to 10, up first 10 seconds. That means we have to find this distance first from here to here. Let's suppose this is 0 and suppose this is 10. So from then 5 to 10, we have to find the distance, this one, and add these two. They're saying distance, not displacement. If it was displacement, just simply use that displacement equation and we would get this small displacement from here till here, this the difference. Okay, but we need distance. That means we have to use velocity equation. What was the velocity equation? We should know that one first. Let's go here. 9 over 40 b plus t. Okay, so we're gonna c2 square. So let me write that one again. V equal to 9 over 4 plus over t plus 1 square minus c t square. Okay. Now we want displacement from 0 to 5 because for distance we need to take help of displacement. So to convert v into displacement equation, we have to integrate it. So integrate its right side also. Okay, so the integration of v is just simply displacement s. And I'm not writing limits right now. First let me integrate this and then I will find that. So 9 over 4t plus it is b t plus 1 minus 2. So we will add 1 for integration and by the same new exponent we'll divide it. So it will be minus 1. That means this sign has to be minus. Okay, and b remains b t plus 1 to the power minus 1 over minus 1, and I'm not writing it because minus I have already written here. Minus ct cube over 3 plus c, and I'm making a mistake because I have to replace the values of b and c. Let me write their values. It was b was 9 and c was 0.1. Alright, this is the integration, and now I want the displacement from 5, so 0 to 5 first, and then 5 to 10. One of them will be negative, and most probably this will be negative. After turning back, this will become negative. So whatever comes to be negative, I'll find the absolute value of that one and add them, not subtract, otherwise it will become displacement. So let me use here. So first 9 over 4t minus 9 over t plus 1. Yeah, this is minus 1, so I can make it positive by making a denominator minus 0.1 t cube over 3 plus c 0 to 5 plus 9 over 4 t minus 9 over t plus 1 minus 0.1 t cube, and this will be 5 to 10. Okay, now 9, first I will substitute 5 here. So 9 times 5 is 45 over 4 minus 9 over 6, 5 plus 1 minus 0.1. 5 cube is 125 over 3 plus c. I have a habit of writing this c which gets cancelled out. Ignoring it totally is not actually mathematically correct, but I'm doing it. So 0. If I substitute 0 in place of this t, I will get what? 0. Now 9, 0 plus 1 will be just 9, so minus 9. And this is t again 0, plus c. And first thing we should do, we should cancel c, because this will be plus c, this will be minus c, cancelled out. Now plus, second, we will substitute 10. So 10 times 9, 90 over 4. 9 over 10 plus 1 minus t cube is 1000, so 100 plus c minus, and this will be the same. Yeah, we have to substitute 5, so this will be 45 over 4 minus 9 over 6 minus let me write 12.5 rather, 12.5 over 3 plus c. Okay, so how much that comes out to be? How much? 11.25 minus 1.5, 12.5 divided by 3 will be 4.17, minus and minus becomes positive 9, these two, so no need, plus 90 divided by 4 will be 22.5 minus 9 over 11 will be 0.82, we can write. Okay, minus 33.3, 100 over 3, c is cancelled out, minus 45, same number, 11.25, plus 1.5 plus 4.17, all are changing sign because we have a negative in front of that. Just put this in a calculator, you'll get your answer. What I get because of the first one is 14.58, and then we get this one as a negative 17.2. So we'll absolute this negative 17.2 and absolute this whole thing, please. Now we know which one is positive, which one is negative. So it becomes 14.58 and 1731.78, and we can round it off to 3 significant figures, 31.8, and what was that? Meters.